Hello and welcome to this short demonstration of our tool ReVision. Short ReVision supports developers in resolving inconsistencies in model-driven software development. Our tool implements a new approach to generate repair proposals, which is based on the assumption that inconsistencies are introduced by incomplete editing processes, which can be located in the version history of a model. Our tool proposes extensions of incomplete edit steps, which are complemented to more complex edit operations, in order to restore consistency in an iterative and interactive manner. We start this presentation with the introduction of our running example, in which we showcase a typical manual editing process. After that, we show you how the resolution of inconsistencies in this scenario is supported by repair recommendations generated by our tool ReVision. We will use a simple model of a video-on-demand system. The system is modeled from two UML viewpoints: a static view, which shows the classes and associations of the system, and a dynamic view, which illustrates the communication in a simple start and stop the video scenario. We now modify the class diagram by moving the operation disconnect from the class video to the class server. This modification will result in an inconsistency in the sequence diagram. The message disconnect is received by a video object that lacks the corresponding operation signature. In general, there are several ways of how to fix this inconsistency. For example, an undo of the previous changes or a deletion of the message disconnect. In our example, we will fix the inconsistency by sending the message to the mirror server. However, this creates a new inconsistency. The sending and receiving object must be connected by an association in the class diagram. This condition is not fulfilled for class user and server. A possible fix is to swap the sender Alice with the lifeline of the video. Now the consistency of our model is restored. We will now show you how our tool ReVision can help the developer to automate this repair scenario. As usual in professional software development, the video-on-demand model is stored in a version control system. The model has been revised several times, as we can see in the history view. We will start with an initially inconsistent version of the model, namely the model version which obtained after the first edit step in our example. To find the inconsistency, we start the validation process. There's one inconsistency found that marks the message disconnect with a validation error, message without operation signature in the receiving class. Now we start the analysis of the model history by selecting this inconsistency. The tool traces the inconsistencies in the model history and stores them in a database. After the last consistent version of the model is found, the tool searches for incomplete edit steps that may be complemented to improve the inconsistency. As we can see, we have found two repair proposals. If a repair is selected, all involved elements are highlighted in the model editors. We can also open the last consistent version of the model to compare it with the current inconsistent version. Here we can find the moved operation disconnect, which is the cause of the inconsistency. For example, we can apply the repair move operation and remove message, which just deletes the message disconnect from the sequence diagram. This fully recovers the consistency of the system. If this decision turns out to be wrong, then we can undo the last repair and continue with the previous model version. Instead, we try to correct the message disconnect. Therefore, we inspect the repair, move operation and synchronize message. We can inspect the historically recognized changes as well as the complementing changes. As we can see, there are two possible receiving lifelines in the parameter list: the main server and the mirrored server. We select mirror, then we apply the repair, which leads to the partially repaired version as shown in the introduction. We finally calculate the second repair, move message, which also corrects the message sender. In the parameter list, we can see the sender open and the already swapped receiver mirror. We apply the repair and finally restore the overall consistency. We thank you for watching, and we hope you got a good impression of our interactive repair tool ReVision. If you are interested in the project, you can find the link to the Eclipse plugin in the video description.